In this video, you're going to learn how to create a virtual machine inside of AWS using Terraform. We're going to create the virtual machine, we're going to add it to a VPC, and we're going to provision an application to it. All of this we're going to do from Terraform. Now, if you've never used Terraform before, if you don't even know what it is, we're not going to delve into the absolute basics of the workflow in this video. But you can see those in the video that's linked in the description below. So if you haven't seen that, go ahead and watch that now. You can always come back here. Right, let's dig in. Now, the first step, whenever we want to do something with Terraform, is we need to add a provider. So what is a provider? Well, let's take a quick look. So a provider is the thing that interfaces with the cloud. So for example, AWS has the AWS Provider. You can see it here on my screen. Now, when we want to use these providers, they're loaded as plugins. So I've already installed Terraform on my local machine, but what I need to do is add the provider to my Terraform configuration. And then when I run that Terraform Init command that you saw in the previous video, Terraform's going to download that provider. So let's just grab the basic configuration. We can go to the provider in the registry here, and then we have this Use Provider button. So I'm just going to click on that, and it provides me with all of the configuration that I need. I'm just going to copy that, and I'm going to go back over to my terminal. And what I'm going to do is I'm just going to paste that into my terminal, into my VS Code. Now I've just put this into a file called main.tf. So let's walk through what's going on here. So Terraform is a specific stanza that defines the configuration for Terraform itself. Now here we have this subsection, which is required providers. And inside a required provider, we're defining AWS. Now inside of AWS, we have the source and we have the version. It's important to always pin the version of your provider because whilst they don't change a great deal, you want to have the configuration that's defined always matching the version of the provider, which from when it was created. So it's just good practice. And again, there's no harm. So let's just add that into there. Now here we have this provider block. Now the provider block is where you can configure certain elements of AWS. Things like the authentication credentials, the region, and things like that. Let's just go and look at those in the documentation. So if you see here in the documentation, it explains how to use the provider, what the various configuration options for it are. So if we just kind of scroll down here, you can see here some examples. Now there's an example there, which is kind of setting the region. If we scroll down a little bit further, we can see the various different methods to authenticate with AWS and the various different ways that you can provide that access key to Terraform. Now, of course, you can do things like hard code the region, the access key, and the secret inside of the provider block, but we don't recommend it because you've got to think that this is potentially going to get put into GitHub. Now, that GitHub could be public, it might be private, but there's an opportunity that those secrets could leak. And if they leak, then somebody else can do whatever they want with your AWS account. So you want to keep them separate. What we're going to do is we're going to configure them as environment variables. And again, if we just scroll down this documentation here, you can see that all of those essential elements, the access key ID, the secret access key, and the region, well, they can all be set from environment variables. So the next thing you're probably wondering is, well, where do I get an access key and where do I get a secret from? Because all I've got is my AWS credentials that I use to log into the console. Let's have a look at that. So what I've done is I've just logged into my AWS console. Now I've just used my username password that I can use to access AWS there. And I've gone over to the identity and access management section. So to my IAM dashboard. So in order to create a user for Terraform, what I need to do is look at my users as IAM resources. And I'm going to create a new user and I'm going to attach policy to it. So let's go ahead and do that. Let's click the create user. Let's call this Terraform Basics. And we're not going to provide access to the AWS Management Console. It's a pure API account only. Hit next there. I'm going to attach policies. And the policy that I'm going to attach is just the administrator access. Now that gives me complete permissions over AWS. What you really want to do when you're kind of refining your IAM credentials for your application is you want to restrict what that application can do very, very heavily. Because again, in the instance that the credentials do leak, the blast radius is limited. But for simplicity, just to get things working, we're going to set this up like this. So I hit next there. That's going to do that. Then I hit the create user button. So my user's now being created. So if I click on the username there, then I can go over to security credentials. And what we can see is we can go down to access key. So I want to create an access key. So I create an access key. I am going to use this with a third-party service. Hit next, confirm. Description, I'm just going to call this dev. And what that's done is it's created the access key. So the access key there, and also the secret. Well, what I need to do is I need to copy those because I'm going to set those as environment variables. So let's just quickly do that. I'm going to copy that secret access key and there. Now let's look at how we can configure this as an environment variable. Okay, so what I've just done is I've just grabbed that secret key and that secret, and I've just added them to 1Password. Now you don't have to use 1Password, but I find that it's kind of a really useful tool, and I'll show you a nice trick that we can use with Terraform in just a second. Now those environment variables, we need to set 3 environment variables. We need to set the access key ID, we need to set the secret access key, and the region. Now the access key ID, that is going to be the access key here that you get from the console. The secret access key is obviously the secret of the access key there. And the region, well, the region, this is where you want to deploy your resources. So in Terraform, for each provider, we have to kind of define that to a particular region. And I'm going to use Central in Europe because that's kind of the closest one to me. Now, if you look at my configuration file here, what you'll see is that I'm actually using 1Password to be able to kind of populate these environment variables. So I'm just defining a sort of a quick kind of statement there, and that's basically just going to do a little bit of a switch to make sure if I'm using Windows with WSL or whether I'm using a Mac to get the right command. And then I can actually use this command here, which is op item get, a name of my secret, and then the field. So, you know, there's no harm at all that I could just completely have export AWS access key ID. And I could have just set that to my value here. Like that. There's absolutely no harm in doing this whatsoever. But with using 1Password, it just gives me a little bit extra protection. The other thing is that you do not want to commit these environment files to GitHub. These need to stay on your local machine. So what I do is I'll just add that to a git ignore. You can, of course, put them in your kind of your profile or anywhere you want like that. But I find that when you're working with Terraform, what often happens is you end up with different kind of sets of credentials for different workspaces you might be using. So entirely up to you how you do that. We just need to set those 3 credentials. Okay, so now they're set. Let's run a Terraform Init to download that provider. So now let's go into my test folder. So I have a folder called a test AWS. I'm actually just working in the example repo that's listed down below, but I've created a new folder inside of here. So we have that main TF, and that's where we defined our provider block. So let's run Terraform Init to install that provider. Terraform, if I could spell it, Init. So it's found the provider and it's now going and it's just downloading it, and it's going to store that locally on my machine. I'll just take 1 second to complete and we're done. So we've got the provider installed, we've got the credentials configured. What we can now do is have a look at creating our first resource. So the resource that we're going to create is we're going to create an AWS Spot instance. And to create a Spot instance, because it's a cheap resource, we're going to use the resource AWS Spot Instance Request. Now again, all of this I find inside of registry.terraform.io in the provider documentation. So there should be an example here that I can probably just cut and paste. And this looks like it'll do the job. So let's just copy this and then let's paste it into our configuration. Over to our configuration, and we're going to put this in a file called vm.tf. Can all go in the same file, it doesn't matter, but I like to keep things simple just to kind of make it easier for me. And then what we're going to do is we're going to have this spot instance. We're going to, well, the name of it, cheap worker. Let's kind of leave that for now. The AMI, now this is the ID of the AMI that's going to be used to create it. So that's the kind of the base operating system, Debian or Ubuntu. We'll set that up in a moment. Spot price is actually an optional parameter. So the spot price here means that if the request is higher than this spot price, it won't get created. But I'm going to remove this for now. And the instance type, well, this is the various instance type that you want. I don't need anything this big. So let's create something that you can create on the free tier inside of AWS. And that's going to be a T3 micro, T3.micro. Okay. And then we have tags. So the tags will appear inside of the AWS console. I don't need to specify tags, but generally it's a good idea. And in fact, when you're using Terraform in production, many organizations will mandate that you specify the tags. And they'll mandate it so that they can track resource utilization across various different teams. But for now, I can just get rid of this. So that defines our spot instance. We need to set the AMI. So where are we going to get the AMI ID from? Well, we could hard code this. And we could set it, but the AMIs tend to change all of the time. So they're constantly versioned. They've got the latest security patches on. So what we want to be able to do is we want to just add the latest Debian. And I'm going to use Debian 11. So where do I get that from? Let's go over to the AWS console and I'll show you the marketplace IDs. So if we go over to the AWS console here, you can see that what we have are the machine images. Now I can actually search for images that kind of matches my criteria. So I'm going to want an image called for Debian 11, and I can see here that there is an AWS marketplace image for Debian, and we can see there's a few of them, but we're going to choose the AMD 64 one. So we could again just copy this AMI ID and we could just hard code it into our configuration. But this isn't the best approach because, as I say, this changes quite frequently. So what we want is the latest version of this image within the family. So how do we do that? Well, let's introduce a new concept in Terraform. And let's introduce a data source. So a data source allows you to look up certain elements. And for example, here we have an AWS AMI data source. So the AWS AMI data source allows me to look up AMI IDs based on the criteria that I specify here. Let's copy this, let's add it to our configuration, and let's start configuring this up. Back over to our config. And again, it doesn't matter where I put this in the file. I'm just going to put it at the top because that'll kind of make it nice and neat for me. I'm just going to change the name here. I'm going to call it Debian. And let's just go through here and delete some of these unnecessary parameters. So all we really want is most recent to be true. We are going to need to specify the owner, and then we're going to need to specify some filters. So the filters that we need, we're just going to specify the name, and we're also going to leave the virtualization type as HVM. So back over to the AWS console, let's grab the name and the owner. So if we scroll down here, we can see there's an AMI here, which is Debian 11. This is a Amazon image, and this is kind of something which we're going to use. First things first, let's just grab the name. Now we're going to just take the beginning of the name there, pop that into our configuration. I go over to my name, and what I'm going to do is I'm going to paste this into here. And this allows me to specify a regular expression. So I'm going to leave the star there. So I want to look up any name which has this prefix, and then obviously this is the date. Now the most recent equals true is going to get me the latest image that's been built and pushed. The last thing I need to change is the owner. So again, let's go back over to Marketplace, and I'm just going to grab the owner ID here, which is going to be Amazon. Let's paste that into here. And then we've got our data element configured. So now when we run our Terraform plan, this data element is going to search Amazon AMI catalog and find me a Debian image from Amazon. So how do we use that? How do we kind of link that up? Well, what we do is we can use this concept called interpolation. So rather than having this hard-coded value, what I can also specify is a link to another resource. So let's do that. Data, we're going to do AWS AMI, which is the one data element we've just created, called Debian, and we're just going to grab the ID. You can see IntelliSense is kind of completing that for me automatically, but we've got that ID. So now this value is going to be dynamically populated whenever we run Terraform. So it's no longer hard-coded. Well, let's give it a go. Let's save this file and let's run a Terraform plan. So running a Terraform plan there. This is now going to connect up to AWS. It's going to convert that configuration that we've just defined into API calls. And we can see here that it's going to add one LM resource, change none and destroy none. Let's have a look at what it's actually going to add. So it's going to add for us the spot instance. The AMI ID you can see there is now populated. So that's come from the data element. All of the other elements, we don't know what they are yet because they haven't been created. We can see our instance type. Everything else looks good. The next step to create that is to do a Terraform apply. So let's just run that. Again, when I run the Terraform apply, it's going to give me the same sort of prompt. It's going to give me the same output that I had in the plan there, but it's going to ask me for confirmation. So I'm answering yes there. And now that resource has been created. Now that happened incredibly quick. Now that doesn't mean that the resource has actually been, the virtual machine's been created in AWS. It means that the request has been created. This is actually an asynchronous request. You'll see later on how we can make this block until the virtual machine has been created. But for now, we can bounce over to the AWS console and we should see that VM spinning up in our EC2 instances list. So if I just go over here to instances, then we can in fact see there that it has been created. So this is the instance that I just created with Terraform a couple of seconds ago. We've got a public IP address. Everything has been created. It's spinning up and everything looks great. Now, this is not particularly useful because we haven't attached this to a VPC where we haven't got any security policy. We haven't got any way to log into it. But we can do that now. Let's have a look at all of those things. Let's start going through and adding the additional resources that we need to create a VPC. Now, the resources that I'm going to add are just exactly the same resources that you would do if you were going to click through the AWS console. We're just using the Terraform representation of them. I'm not going to go into detail for each resource. You can find that in the documentation. So for example, let's add our first resource. The first one we're going to add is the VPC. Now, a VPC resource, again, we define like this. So it has the resource indicator here. So it has the resource block name there. It has the type of the resource, in this instance, in AWS VPC, and then the name of it that we can use to reference from our other configuration elements. We have to specify a few different bits and pieces here. The CIDR block, well, I'm going to specify a CIDR block here of 10.1.0.0. And we're going to enable DNS host names and also enable DNS support. If we go over to the Terraform documentation and have a look here at the AWS VPC resource, you can see all of those different kinds of options there. There's also some bits and pieces there. So the CIDR block, this is exactly the same as what you would configure if you were going to use the AWS API, or probably it would be a box inside of the console. But for a bare minimum, those are the only fields that we need to add. Right, let's go through next. So what else do we need to create? Well, what else we need to create is we need to define a subnet. So a subnet for the VPC. So let's have a look at this because this is quite interesting. So I have a resource here, which is my subnet. And I've specified a CIDR block. Now, the CIDR block has to be part of the CIDR block for the AWS VPC. So for example, this is going to be linked to an availability zone. If my CIDR block here is 10.1.0.0, I might create 3 sub blocks, which are 10.1, 10.2, and 10.3, for example, for each of the different availability zones. Again, rather than hard coding those, what I can do is use a Terraform function. So Terraform function is something which is built in, which enables me to do certain different calculations. This one will enable me to derive a subnet from a CIDR block. So again, let's have a look at this. As a function, I'm using the function name CIDR subnet. I specify my CIDR block, and I'm using a reference to the previous resource. Now, just to kind of recover from what we learned in the very basics video, whenever you use a reference like this, what you're doing is you're telling Terraform that it can only create this resource after it's created any resources which are referenced by it. So in this instance, the AWS VPC will be created first, and then the subnet will be created. So we're specifying that there. So we're just giving the parameters, and the parameters are the CIDR subnet, the bits that we're going to add to be able to calculate the new subnet, and the number of the subnet that we want. So for example, let's take a look at the documentation for this. So the documentation for this particular function is here. So again, we see that CIDR subnet, the prefix we want to use, the new bits, and the net num. So for example, you can see there's an example that if we start with a subnet of 172.16.0.0.12, and we add 4 bits and we ask for the second, then what we're getting is 172.18.0.0.16. So it kind of, if we specified here as 3, then what we would get then is 172.19.0.0. It's just a really simple way of being able to kind of manipulate that subnet and do it in a dynamic way. Functions are very, very useful in Terraform, and there's lots of different functions and you can use. They're not restricted to just things like IP subnet manipulation. In the documentation, you can see we have numeric functions, so I can calculate absolute values of things. I can specify things like parsing integers from strings, string functions, which can kind of validate if something ends with something, whether you want to get the substring from a string, collection functions. There's quite a comprehensive list of those, and I think it's worthwhile spending time to look through those because it will save you a lot of time if you learn a few of those different bits and pieces. Let's pop over back to our configuration and let's keep going. So we got the VPC defined, we've got the subnet defined. Let's now add our gateway. So the gateway we need to connect to the VPC, so in order we can have external traffic. And again, what I'm doing is I'm just defining that resource, and then instead of hard coding the VPC ID, because I don't know what that is, it's created by the resource here, I'm linking it. So I'm getting the ID, which will be available after creation, and I'm just going to specify it there. Again, Terraform now knows that in order of creating resources, it will create the AWS VPC, and then it will attempt to create the subnet and the internet gateway in parallel because they both are dependent on the VPC. The next resource that I want to create is a routing table. And the routing table is needed so that we can kind of route traffic out from our subnet to our internet gateway. And I'm going to allow all traffic external to go over that internet gateway. I'm just specifying the route there. And then what we need to do is just associate that with the subnet. All of this configuration is kind of standard that you would do when you're creating an AWS VPC. There's nothing really specific with Terraform other than I'm just defining those entries using Terraform configuration. Next step, what do I want? Well, I need to define a security group. So the security group is going to specify the ingress and the egress for my particular resource. Now, what I'm going to specify is that I'm allowing traffic in on port 22 because I want to be able to SSH to the machine. Egress, I'm going to allow everything to all resources. We specify that there. Now, if we go and specify another resource, what we need to be able to do is to log into the machine. So how do we log into the machine? Well, we need to use an SSH key. I have an SSH key on my machine here. The public part of it is stored in temp. Now, if you don't have an SSH key, you can search Google on how to create one. It's fairly straightforward. But what will happen is that the public part of the key gets added to the virtual machine. And then when we try to log into it, our SSH terminal is using our private component, which the server is using then the public to validate that the request is valid. And it'll allow the authentication. So we specify that there. So now we've got all of those resources added. Let's also reference them in our spot instance request. So the first thing we're going to do is we are going to add the public IP. So we want to associate a public IP address with our machine. And the next thing that we're going to do is we need to specify the key name. So the key name, we're going to reference that resource that we created earlier. So the AWS key pair, just type that in there, AWS key pair, open web UI, and then we want the key name there. And then what we want is the VPC security groups, and they are going to be just a list of security groups we want to apply to the VPC. We've only got one, which is SSH. We're just adding that. And then we need to obviously add our subnet. And again, I'm just kind of referencing that there. And lastly, we're going to wait for fulfillment. And this is going to mean that Terraform is not going to return until AWS has actually created the the AWS spot instance. Now, when I've been kind of adding those parameters, you can see there that IntelliSense has been completing a lot of things for me. And that's because I'm using the Visual Studio plugin, which gives me a Terraform language server. The other thing is that GitHub's Copilot is also really good at understanding Terraform. So it can give me a lot of help and suggestions. Both of those things I really recommend to make your life a little bit easier. But we've got all of that done. Let's go and run Terraform apply. So I'm just running Terraform plan, the command there. And Terraform's doing that check. It's kind of just evaluating my configuration, processing it. And we can see we've got some errors here. So let's have a look. Okay, so Terraform is telling me that I can't actually set my CIDR value to be 10.1. It's telling me that actually I need to set that value to be 10.0. And this error message is coming back from AWS. So that's nice validation. So immediately before I make any mistakes, I can go and configure that. I can change that. Let's find our subnet VPC, and we're going to change that address. So let's run Terraform plan again. Well, we've still got an error message, but Terraform's kind of holding our hand here. It's giving us a good help of what we need to do. We need to just set the sort of the bits there for the net mask to either 16, between 16 and 28. So let's just change that. We're going to change this here to 16, and hopefully this time it's going to be fine. Let's go and run Terraform apply. So we're running Terraform apply. Now Terraform is going to add some resources, and it should tell me that it's also going to delete one resource. And I'll explain why in just a second. So it says it's going to destroy one resource, and the resource that it's going to destroy is the spot instance request that we created. And the reason that it's going to destroy that spot instance request is that we're making some changes that are not mutable. So we're doing things like adding it to a subnet. We're changing some of the things like the key that's going to be used to log into it. And none of that is mutatable. So Terraform understands that. It's smart enough to understand that it has to destroy it before it has to create it. So I'm just going to go and answer yes. We can see there that Terraform is now doing that destruction. And if we go over to the AWS console, and then let's just refresh that. Well, you can see there that that machine that we just created previously is currently shutting down. And that'll take a second or two to shut down. And to destroy, and then Terraform's going to go ahead and it'll create the remaining resources. So the machine's now gone. We can see the destruction's complete. Terraform is creating our VPC. It's adding our SSH key and the rest of our resources. It's now creating our spot instance. And if we go over to the console and then just refresh here, you'll see that it's actually already done. So that instance now exists. We can see there's our public IP address, our private IP, which is in the range of our CIDR block that we specified, and everything else as we configured it. To log in, I could just copy and paste this public IP from the console, but there's a better way to do it. And that is that I can reference that public IP from the Terraform configuration, and I can return it using an output variable. Let's have a look at that. So an output variable in Terraform is a special type. What it allows me to do is to kind of specify a value, which can then be output to the CLI, and I can have various different bits of information there. In this instance, I want the public IP. So I'm going to set the value of the output to be the public IP, which is returned from the spot instance request. Now, the public IP is only assigned after AWS has created the virtual machine. Again, you have the benefit of that graph that Terraform knows that to be able to create the output, it has to wait until the virtual machine is completed. Let's run apply here, and then let's create that output variable. Terraform apply. It's going to wait for that. It's going to check our configuration. It should tell us that it's going to make one little change, and then we'll answer yes. And there we go. So now, whenever we run Terraform apply, we will see those outputs. And you can see there that we have the public IP there, 369, blah, blah, blah. So we could just copy and paste, but there is another little trick. Now there's a Terraform command called Terraform output. Terraform output. And then if I just specify Terraform output, it will show me all of the output variables inside my configuration. But I can specify just one specific variable. And I'm going to just specify public IP. Public IP, and you can see that now it's just outputting the public IP. Now, one thing you need to note is that it's returning the kind of the representation of this from Terraform. And in that case, it's a string, so it's adding these speech marks. I don't want that. So what I can do is I can add an additional flag, which is raw. And now Terraform is just going to spit out the public IP in complete plain text. So why is that useful? Well, that's useful because what I can do is I can actually use this as part of a command. So let's have a look here. I'm going to do SSH, and the username, the default for the Debian instance that I'm using is admin. I'm going to do admin at, and then I'm going to specify a subshell. I'm going to do the subshell, and the subshell I'm going to use is Terraform output, and then I'm going to specify that public IP. So when I press return now, I've got that SSH command. It's all dynamic. You can see there, am I sure I want to connect? Yes, I am. And I've now logged into my virtual machine. So what we've learned so far is how to set up that virtual machine in AWS using Terraform. We've seen how we can declare an output variable in order to be able to get the public IP address. And because we'd already assigned the SSH key and things like configuring the VPC security groups, we can actually log into it. Now, let's have a look at how we can provision an application to this. But first, why don't we clean up what we've done so far? So Terraform plan will show you the changes that you're about to make. Apply will apply those changes. Destroy will actually clean up and remove any resources that you've created. So let me just run that command, Terraform destroy. Terraform is going to tell me what it's going to destroy. So again, it's going to look and see what it knows that's been created. And it's telling me there that it's going to destroy 8 resources. So I'm going to answer yes. And those things are going through them. So they're now getting destroyed. If I go over to my AWS console, and let's just go back to our instances and wait for this to refresh. Well, you can see now that it's shutting down. So that virtual machine that I just created before, it's shutting down. The beauty of this is that when I run Terraform apply, because it's all everything is coded in my configuration, I'm pretty much going to get to exactly the same state every single time. And because I can run destroy and clean up after myself, I don't need to leave anything hanging around. If I only need a virtual machine for a short period of time, then I can just create it with my Terraform configuration and then destroy it, clean up, save costs, all nice and easy. All right, so that's all done. We can see the resources have been destroyed. Let's have a look at how we can provision an application to our virtual machine as part of that Terraform configuration. So let's have a look at how we can provision an application to this AWS Spot instance. So pretty much all virtual machines that you're going to be dealing with, no matter which cloud you're using, will allow you to apply a provisioning script, a Cloud Init script, after the virtual machine has been created. With this AWS Spot instance, we can do just that. Let's look at the configuration in the docs, and you'll see that what we can specify is user data. So we have these two parameters here, user data and user data base 64. So user data base 64 allows me to specify just a bash script, which will run whenever the virtual machine is created. And I've got a bash script here, which is going to install and set up some bits and pieces for my virtual machine. What I'm going to install is an application called Open Web UI. An Open Web UI allows me to run LLMs locally, but it also allows me to do things like define an interface to connect up to Open API. I can use this for testing various different LLMs. If I need a local LLMs to be able to do some RAG-based work, I can have all of that running locally. It's also just kind of a nice little application to kind of show you. Whatever we kind of do here, you can use these concepts to install any application that you want to install. But let's have a look at that script. So as I mentioned earlier, what we're going to do is we're going to specify a script that will be run at startup time whenever we create that new Spot instance request. And I've got that script here. It's called Provision Basic, and it's in the repo, so you don't need to worry too much about this. But it is just a bash script. I'm going to run through this line by line just to kind of explain what's going on. So a standard bash script, we're just kind of setting the environment there so that it will fail if a single command fails. And then we're just going to run a series of commands for setting up that virtual machine. So I'm specifying that the Debian front end is non-interactive, make sure that any kind of visual prompts that might happen from the CLI commands are just kind of dealt with. And then we're going to install some packages. So I'm just running apt-get update, and I'm installing certificates, curl, SQLite, and Apache 2 utils, so a couple of utilities. And then what I'm going to do is I'm going to set up and install Docker. So this setup and install of Docker just comes from Docker's installation. You can kind of go over there and you can kind of have a look at that, but we're downloading that, adding the repository to apt, and then we could go ahead and install Docker, the Docker CLI, and BuildX plugins. We're going to run Open Web UI inside of Docker. And we're going to kind of just run that, and we'll set up a startup job to be able to make sure that kind of runs immediately. Open Web UI is packaged as a Docker container, so it makes it really easy to kind of get things running like this. Now, in order for Open Web UI, we're going to need to set up some configuration. We need a data folder to make sure that it kind of persists and that if the machine reboots, we don't lose anything, because Docker containers are mostly immutable unless we mount data volumes. So let's set that. We're just creating that directory on our virtual machine. And then what we need to do is we need to specify the password. We're going to specify a password for Open Web UI because we don't want everybody to use it. It's going to be open to the public because we're going to expose this as a public IP. So let's make sure we're configuring it. And again, just from the instructions for Open Web UI, I'm just following those steps. And I'm generating my password, and I'm encoding it using HT password. One thing I want to make you kind of very aware of is that I am hard coding that password. I'm hard coding the password, and I'm hard coding the username. I've already said that we should never really do this. We shouldn't encode secrets and hard code them. We should always make sure it's dynamic. And we're going to look at this. We'll come back to this in just a moment. We will make this dynamic, I promise. I'm just going to start Open Web UI, and all that's going to do is it's going to kind of create that basic initial database for the authentication. And then I'm running this SQL command, which is going to update the Open Web UI authentication database with the username and password. And again, all of this is from the instructions there. So that Open Web UI starts whenever the virtual machine starts, let's create a systemd unit. And I'm calling this Open Web UI. It's a simple systemd unit. It requires Docker, so it will always start after Docker. And we're just going to run some commands. So I'm running a pre command, which is going to stop any existing instance. Now, if I'm using this %n here, I can actually reference the name of the unit. I'm going to remove that Docker container, and then I'm going to run the new one. So I'm running my Docker container. I am specifying that I want it exposed on port 80. And I'm setting some environment variables for this. And we can see there that we're just mounting the volumes into the directory that we created. And we are also just going to go through here, and we're going to kind of specify the name and the name of the container that we want to run, which is the Ollama instance of Open Web UI. For that to run, I just do a daemon reload, I enable the service unit, and then I'm just going to start it so that on that first start, that first instance, we'll have Open Web UI up and running. So that's my provision script. You could install and set up whatever you want there. It's just a bash script, so you can kind of configure how you want. So we need to be able to add this. So we're going to do user data, and we want to specify the base64 version of user data. So we need to specify our file, our provision basic sh, as a base64 encoded value. Terraform functions, we're going to use two more. We're going to use base64 encode, and base64 encode will take a string and it will encode it in base64 format. So to get that string, we can use file, and then we can specify the name of the file here, which is going to be path.module, and the file is stored in scripts. So provision basic. Copilot is getting a little bit too excited. Provision basic.sh, and then that's specified there. So look here what we're doing at this interpolation. So this is interpolation in terms of Terraform. I am specifying a value, but I'm using a function. Here's interpolation as well. So I'm just assigning a value to a parameter from a previous resource. If I want to kind of do that inside of a string, I have to use this additional syntax here. So this dollar curly bracket. And then I can kind of do that to tell Terraform that it needs to escape that. So I'm using this special value path.module, and this is going to give me the absolute path of where my Terraform module is, where my vm.tf is. So now I can just specify the kind of the relative part, which is scripts and provision.basic, and I don't need to worry about any hard-coded paths or anything like that. So that's all we need to do to get this up and running. But the thing is that this is now going to take a little bit of time. The spot instance request will only wait that the machine has been created. It doesn't wait for the cloud init script to finish. So let's have a look at some ways that we can kind of work around this. I'm going to add a new resource, and I'm actually going to add a brand new provider. And this provider is called TerraCurl. And basically, it just allows me to curl an endpoint, and it will complete once it gets a success. Let's have a look at the docs on this. So here we go. Here's Terraform, created by my good friend DevOps Rob. And TerraCurl allows me to create this TerraCurl request. Have a look at the example here. So the request here is basically just exactly as you would see as a curl request. Now, because I can specify the response codes, and because I can specify things like retries and the amount of time to wait, I can ensure that only when TerraCurl returns the correct response, once my machine is up, once my application is installed, will Terraform continue. So I can basically use it to block until that virtual machine is up and running and that the virtual machine is all healthy. So let's add this as the provider. So let's go up to the documentation. I'm going to use the provider. I'm just copying TerraCurl there, and I'm going to add it to my providers block. Back over to my main.tf file, and I'm pasting this in. As I kind of mentioned earlier, you don't have to do this. You don't have to specify the providers inside of the required provider block. Terraform will try and figure it out, but it's always best to try and do that and to pin the correct version for your configuration so you don't need to worry about any mismatches. So now let's add that TerraCurl resource. I'm going to go over here and we are adding our TerraCurl request. So again, it's a resource. Type TerraCurl request and the name is just Open Web UI. Now what I'm doing is I'm specifying the URL that I want to call. And the URL is going to be the public IP address because our application is running on port 80 of our public IP in our VM. The method that I'm going to use for the curl request is just going to be a get, and I'm going to wait for a 200 response. So I'm specifying the maximum number of retries, which is 120, and the retry interval, which is 10. And that's 10 seconds. So every 10 seconds, I'm going to try to see if the virtual machine is created. And once I get that 200 response, TerraCurl will return. So this will, in effect, it's going to block for 20 minutes until everything is up and running. Before we can kind of do that, if I run this now, it will fail because we need to add a new security group which allows port 80. So let's go and add that to our configuration. And we're just adding a new HTTP security group. We are specifying that we want to map port 80 to port 80. And again, we're specifying that egress for everything. I also need to update my list of security groups here on my VPC. So I'm specifying this one here. And I'm also going to specify the HTTP ID. And we can save that. So that's all we need to be able to do. Let's run Terraform apply and see what's going to happen. Okay, so Terraform apply. So you can see there that I've got an error message. And Terraform's telling me that the lock file is out of date because I have this new provider defined in my provider block called TerraCurl, but it's not in the lock file. So every time I add a new provider, I need to run Terraform Init. Terraform Init, that's going to then download TerraCurl, add it to the AWS provider in the local cache, and then everything's going to be great. And we'll be able to run that Terraform apply again. All right, so Terraform apply is telling us it's going to add 10 resources because we destroyed everything previously. So we're just answering yes there. And of course, now Terraform's going to go through, it's going to create our VPC, it's going to create our SSH key, our virtual machine, and everything's going to kind of run. Now the spot instance is created, so you can see that there, that the creation is complete. Let's look at the terminal, or the console. Just refreshing my instances there, and you can see now it's running. Now the virtual machine is running, so what AWS is now going to do is it's going to execute that cloud init script that I just specified. So that's going to now run in the background, and TerraCurl is going to keep retrying port 80 for that virtual machine, and it will only stop my Terraform configuration once it gets a success of 200. And that's going to take a couple of minutes because we have to wait to install those various different applications, install Docker, install Open Web UI, and wait for it to start. So let's just wait for that to finish. So you can see that that's now completed. The TerraCurl request is completed. If I just log into that machine, so I'm just going to SSH into it. And then if I have a look at Docker Well, we can see there, the Docker is working. Everything's all good. The application's running. We should be able to actually log into this with our browser. So that's everything up and running and everything's working. We've got that application provisioned there. We can see it's all working and we can log in. But the username and the password that we configured, we set that up in the script to be hard-coded. Let's have a look at a better way of doing this. Let's have a look at variables and see how we can use variables to make things more dynamic. So I'm going to go back over to my configuration here. And what I'm going to do is I'm going to add some variables. Again, it doesn't matter where I put variables. I could put them into a specific file called variables. I'm just going to put them in main.tf here. But it really doesn't matter where you put them. As long as they're in a file in the same folder, Terraform will find them and pick them up. But we're going to create a variable. And the variable looks like this. So we use this variable to define the block, and then the name of the variable, so Open Web UI user. Now we can specify a description, and the description is really useful for any sort of documentation that you may have. We're just saying that it's the username to define Open Web UI. And then we're going to specify a default. So the default can be overridden. There's a number of different ways I can do that with a CLI, with an environment variable. But I can also specify like a base value. And I'm just going to set this as admin.demo.js. The other thing that I want to be able to do is, because the instance that I'm using is very, very small, well, Open Web UI can actually work with an Open API key. So I can actually use Open Web UI, but it'll just proxy the requests across to OpenAI rather than running things locally. So if you've got an Open API key, then you can we're going to add that as a variable as well. If you don't have one, you can get one from OpenAPI. It's relatively inexpensive for the number of requests, and it's worthwhile for playing around, especially if you're doing any investigation into AI. But we're going to add two new variables where I can add that key there. I'm adding OpenAI base, and this is the base URL for the OpenAI API. And the default for this is https api.openai.com/v1, and then my key. So my key is something that only I have. So it's a secret that I need to specify to my configuration. So you'll notice that I'm not specifying a default for this. I'm leaving it blank. I need to be able to inject that key every time I sort of run my application. And to be able to do that, to be able to inject it, then again, I can use an environment variable, or I could use the Terraform CLI. So if I wanted to specify it as part of the Terraform CLI, I would run a command like this. So I would run Terraform apply var OpenAI key, and then, the value of my key. But I can also set this as an environment variable as long as the environment variable is prefixed with tf_var. Let's have a look at that. So I can set that Terraform variable using this environment variable. So this is the variable name, OpenAI key. And to use an environment variable to set this, all I do is prefix my environment variable with tf_var_, and then the name of the Terraform variable. So here you can see I'm setting tfr_OpenAI_key. And again, I'm just getting that value from one password. You could just hard code that however you kind of want to manage it, but I'm using that one password. It just kind of makes it easier for me. But what this means is that when I run Terraform plan or Terraform apply, Terraform will automatically set the environment variable here, OpenAI key, from that environment variable, which means that I can kind of keep my configuration all dynamic and nice and simple. So let's see how we can go and use this. So the first thing is, let's go back over to our template. So here we're base64 encoding, and we were loading this file. Now, instead of loading the file, what we can do is we can use a different function, which is template file. And what template file allows us to do is specify an additional parameter, which is going to be some variables that we can kind of inject into this configuration. So I'm specifying that there. So I'm just using this notation here, these curly brackets, where I'm going to specify my variables. So the variables that I want to add are my, well, OpenAI web user, and I'm setting that to my Terraform variable, open web UI. I'm specifying my OpenAI base and my OpenAI key. So those are just coming from these Terraform variables here. Now, how we use those is we can actually use the template syntax. So let's modify our provision script, and let's modify this to be able to inject and to use this and make it more dynamic. So first things first, I've just made a copy of my provision script. I'm calling it provision vars. Here's my script that I was using earlier. Now, the first thing that I want to do is to specify that username. So this was the user that we had hard-coded. So we're using this interpolation syntax, this template syntax, and we're going to specify open web UI user. So this is the variable that we defined in our configuration over here. So open web UI user, that's coming from the Terraform variable. The Terraform variables are not automatically injected into this template file. You've got to very explicitly define which ones can be used. So we set that there. So this is now dynamic. Now what we also want to be able to do is we want to be able to add those environment variables for our OpenAI. So again, let's just add an update to our block here. And what we're going to do is we're going to add a conditional. So the template can also be conditional. So we're saying here, percentage curly bracket, if OpenAI underscore key, so that is this variable here. Well, if this is not a blank string, what we want to do is we want to write OpenAI key to this particular file. And we want to do the same thing with the base. With systemd, what systemd can do is systemd can actually load an environment file. And the syntax for that is basically just this. Here you have the key value pair. So what I'm going to do is I'm going to set that environment file, and then I can use that from within my systemd unit. So let's kind of just have a look at how we're going to do that. Again, we're just going to reference that here. And environment file. And then we're just specifying the path. So the path is as we're writing it there. So etc. open-web UI-d, openwebui.env. And then we can then reference those environment variables as part of our start command. So our start command is just the command which is the docker run. We're adding this environment variable API key and the base URLs to our docker run command. So we can just add those here. We're just going to specify this like this. So open, specify that here. So open AI base and open AI key. And what this is going to do is this will all be interpolated whenever that systemd unit is created and the command is run. So it's going to add the OpenAI key to our application. So far, so good. But we're still not perfect, because if we go back a little bit, we still haven't dealt with this password. So what about this password? Do we want to inject the password as a variable? Well, we could, but there's another option. And the option is that Terraform actually has a random provider. So Terraform can actually generate me a random password every time it runs. So let's take a look at the random provider. So the random provider can do a few different things. It can generate things like random IDs, random numbers, random pets, random passwords, which is what we want to use. So we want to generate a random password that we're going to use for Open Web UI. And we can kind of specify the length and whether we want to use special characters and things like that. So let's just grab the provider details that we can then pop into our required providers block. Just over here, we can just add that in there. And then what we can then do is we can then add a random resource. So let's just add that. And I'm just going to add that just up at the top here. Doesn't really matter. But this is where I'm going to add it. So I'm just adding, so I'm just going to add my random password, and I'm just calling it password. The length is going to be 16, and I'm not going to use any special characters. I'm just going to kind of set that like that. So what I can then do is if I go down to my configuration in my template file, then I can also now add open web UI password, and we're just going to set that to be the result of our random password. So that's all good there. And then if we go back over, just over to our provision vars, then we can just use that in here like so. So open web UI password. So we've now got the web UI password and the user. Both of those are going to be created dynamically. We're also adding our OpenAI base, our OpenAI base and our OpenAI key. So everything's good there. Last thing we want to add is that password. Well, we're going to need to be able to use it. So let's also add an output variable for this. So we're just going to add an output variable for password. We're marking it as sensitive. And when we mark something as sensitive, the Terraform CLI will mask the output. It's not just going to always put that out there. And that's in case you're running Terraform on CI or something like that. So we're just going to initialize to download that new random provider. And we've got that done there. And now we're going to run Terraform apply. This is run our Terraform apply here. Okay, so Terraform's telling us that there's an error. So again, we get that nice validation. Terraform is checking our configuration. It's running through everything. It's stopping me from kind of making any mistakes once that all of this is in flight. And it's telling me that, well, I've called the variable Terraform pass and I'm referencing it as password. So let's just fix that. If we go back over to VM, we just change this to password. And you can see there that I'm just using it as password. So again, Terraform is inspecting that template, and it's even checking that the variables I am injecting those for that template to run correctly, which is actually really nice. So Terraform apply. We can see there that we've got a couple of changes. Let's have a look at this. The changes we're going to make is that because we're changing the details for that virtual machine, we also need to kind of destroy that and need to create it because the cloud init script has changed. Terraform's smart enough to understand that needs to kind of change. So let's just go ahead. We're going to do that. We're answering yes, and we're just going to need to wait now for this to complete. Okay, so this is completed. So let's just grab that IP address and let's just open this up in our browser. So we have the open web UI. Let's just type in our username. So admin@demo.js, and then we need our password, which we can get from Terraform because that was part of the random provider. Now you can see that because we marked that sensitive, it doesn't automatically output there, but we can get it if we explicitly just say Terraform output password, and there's the password. We can just copy this, and then we can use that to log in. Okay, so that's everything working. We've logged in there. Let's see, we can see all of the models because we've hooked this now up to OpenAI. So let's just use, let's have a look at GPT-4, and then let's ask it a question. So let's have a look. What are variables in Terraform? Let's see what GPT-4 has got to say about that. So it says the Terraform variables represent code. So we got everything working, and this is pretty good. What about complex variables? Because a variable can be a string. So let's ask GPT-4, can I have different types of variable other than string? Well, GPT-4 is telling me that I can actually have strings. It's telling me I can have numbers. And it's telling me booleans, lists, and more sort of complex types here. So we can see there. So let's have a look at this, because actually maybe what we can do is we can use some of these complex types to make our configuration even more dynamic. Because whilst it's good that we can use OpenAI from OpenWebUI, the real beauty of using OpenWebUI is that we can run LLMs locally. But this small T3 Micro isn't capable of doing that. We also need to make some changes to be able to enable things like install the NVIDIA drivers and stuff like that. So let's modify our configuration one last time, and now let's see how we can kind of make some of those changes to make things GPU enabled. Let's add a couple of new variables. If I go back over to my main file, and then let's add a new variable here, and we're going to add a sort of a more complex variable. So the variable that we're going to add is going to be called machine. And this is actually going to be an object. So what we can do here is we can define the type of virtual machine that we want. And we can kind of say, well, hey, if it's a GPU, we want to use a G4DN X large. And this type of virtual machine has an NVIDIA A100, I think, attached to it. So a GPU attached virtual machine. And of course, if it's just CPU, we can use this T3 Micro. Now we're going to add another variable here. And what we're going to do is we're going to have this variable say, well, if we're running our configuration with GPU enabled, then that's going to be the thing that we can use for the switch. So how can we do that? Well, we can actually use sort of conditional statements inside of Terraform as well. Let's see how we can use these two variables with a conditional statement. So back over to our VM. Here we've got the instance type and we've got it hard-coded as T3 Micro. Let's see how we can use a conditional statement. So what we can do is we can say var.machine. If we say var.GPU enabled, and then we're going to say, so if that is set, what we want to do is we want to use var.machine.gpu.type. And then otherwise, we're going to do the var machine CPU type. So go back to our variables again and just have a quick look at those. And you can see, so if GPU enabled is set to true, then what we're going to do is we're going to use the type from this variable here. So if the GPU is set to true, we're going to use the type here. Now I can actually use this dot notation when I'm accessing the variables because this is a sort of a more complex type of variable. It's an object, and that object has a key called GPU. It also has a key called type inside of GPU. So that enables us to do that. What we also want to be able to do is we want to be able to update our provision script to be able to kind of do some stuff when we are GPU enabled. So let's go over to the provision script and let's add that. So I'm just going to go over to my provision script here, and just beneath where I'm setting that open API key, what I'm going to do is I'm just going to add a new bit of my script there. And it's going to look like this. So if GPU is enabled, what I'm going to do is I'm going to set the Docker GPU flag. And that means that my Docker is now going to use the attached GPU. So I'm writing that to the environment file like I did with the OpenAI keys. What I'm also going to do is I'm just going to install the NVIDIA driver, the NVIDIA container toolkit, and then I'm going to configure my Docker runtime to do that. And we can kind of set that up there like that. Now again, I have that conditional there inside of that template to be able to kind of do that and set it all up. So I can just go ahead and let me just also add the GPU flag to my start command. So that's going to add that in there. And then what we can do, if we go back over to our virtual machine, we're going to need to add that GPU enabled to our template, GPU enabled, and we're just setting that to our variable. And this should be enough. One last thing, actually, sorry, we need to change. Now, rather than kind of starting the service, if we're GPU enabled, then when we install the NVIDIA toolkit, we actually need to reboot the virtual machine. So let's just change this here to reboot the VM after we've done that Cloud Init script. And that'll be fine if we're using CPU or we're using the GPU enabled. One final thing that we need to do is we also need to update this spot instance request, because by default, the spot instance, I think, has something like 8 gigabytes of disk space. And that isn't going to be enough when we want to kind of install all of these GPU drivers and things like that. So we're just going to set an additional parameter here, which is root block device, and that's going to allow us to control what size of base disk we want. And we're setting that to 60 gig. So this is all good. Now what we can actually do is run our Terraform apply again, but we're going to specify GPU enabled. GPU enabled by default is false. We want to set it to true. So we can do Terraform apply /var GPU enabled is true. Going to press return there. Terraform's going to process that configuration. You can see it's going to destroy 2 resources and it's going to add 2 resources. So if we scroll up here to our new VM that we are creating, and then let's just keep going up and up and up until we can find the instance in here somewhere. There's a lot of properties on this thing. Well, so what you can see here is that Terraform is telling me that we're going to change the instance type from the existing T3 micro to the G4 DN X large, which was based on that interpolation that we added in there and that conditional statement. And it's also telling me that that's going to force a replacement of the resource. So I'm just going to answer yes to this. Terraform is going to now destroy the virtual machine. It's going to create the new one. We have to wait a few minutes for this to kind of create and provision again. But once it's done, we'll have our GPU instance as opposed to our CPU instance. Okay, so that's finished. So let's log in now and see how this is all working. All right, so we're logged in. We've got the ability now that we can kind of use a local model. So let's specify Mistral. And we're going to pull a Mistral from Olama. So this is going to kind of download the local Mistral model, because we're now running this GPU instance. We can now run these local instances. The benefit of doing this as well is we can also have a local RAG-based process. So we can get our local LLM to interpret any documents or anything like that we upload. It takes just a second for that to install and verify. And now that's done, we can select it and we can ask a question. So let's ask it, how do I define a Terraform variable that is a list? And we'll see what Mistral can do when it's running locally. So it's specifying there that we can define a variable as a string using square brackets. And actually, it's got that right. So as a local LLM, just using Mistral there, that's pretty awesome, pretty great. This is kind of everything that we kind of want to learn on the basics on how to create a virtual machine in AWS. Of course, I've just used Open Web UI. You could use anything you like. You could set up your own virtual machine for doing any AI experimentation. Maybe you want to do some training. You can install anything you want just using that Cloud Init script. I could set up Python or Jupyter or anything that I wanted in there. The process that we've kind of gone through inside of this video is going to be exactly the same. You just need to change some of those parameters. So you've seen how to define this kind of Terraform block and how to add providers to this to ensure that whenever the configuration is run, it always downloads the right provider version for the configuration that you've got defined in your script. And we've also seen how to configure that provider. So we've looked at how we can configure AWS here to inject the secret and the access key ID using environment variables. We've seen how we can make configuration dynamic using variables, and we've seen that there's kind of a couple of different types of variable that you can have. You can have this basic variable, which kind of just is a string, or we can have more complex types of variable, which are using kind of objects or lists or things like that. You've also seen how you can use data elements and how data elements can do things like query and AMI. So I'm always ensuring that I'm using the latest version of the Debian AMI. And we've seen how we can kind of mix and match a couple of different providers. We don't just have to use only AWS. We're using random, we're using TerraCurl. We're kind of setting all of that up here. And you've seen that by defining these different resources, we can actually use things like functions. We can use things like interpolation to control the order that the Terraform resources are created. And ultimately, you've kind of seen that full working example where we piece all of that together, creating the VPCs, creating the SSH key, and ultimately also the spot instance there. And that's it. We're done. So the very last thing that we're going to do is we're going to clean up after ourselves. Don't forget, Terraform destroy. Terraform destroy is going to remove all of those resources that we've created. It's going to stop any expensive costs. And again, because I can just run that Terraform apply, I can create this thing again later on whenever I want. That's all for now. Hope this has been interesting to you. Thanks very much.